Okay, I realized that my mic was off the whole time.
Yeah.
All right. Okay. Thanks, Marc.
Yep.
All right, then let's try this again. Hello, everyone. Welcome to our channel. And we've been running those events. Yeah, so we've been seeing a bunch of people saying we have no sound. Hopefully this is good. So welcome again to our channel. We've been running those virtual events on our channel for quite some time right now. If you've attended previous events on our channel, welcome back. And if this is the first event that you're attending, welcome to our channel. Today we're joining we have a very cool event for today. We'll be talking about basics and fundamentals of Spring Cloud Stream, AsyncAPI, and we're going to be using the event portal to develop a very cool app. So this is going to be a very interactive session, and we would be requiring, it'll be great to have interaction from the audience, whether you have questions or if you have any suggestions. We'll be doing some live coding. Feel free to ask us on the chat window, whether you're joining us from YouTube or Twitch. And yeah, that would be great. Before we get started, I'd like to ask anyone who's joining us, let us know where you're joining us from. So type in the channel, in the chat window down below, where are you joining us from? What city, state, or country? I'm currently joining you guys from Ottawa, Canada. It's pretty rainy today. That's why I'm wearing a sweater. And in fact, I'm wearing an AsyncAPI sweater. So if there's anyone from AsyncAPI, this is a shout out to you. Thanks for the sweater, for giving me the sweater. I'd be quite interested and intrigued to know where people are joining us from. As people are coming in on YouTube and Twitch, I would like to point out that we have a Solace community. So you can see the link down below on solace.community. We are giving out some swag to people who are joining the community and asking us questions. So if you join the community, you get the opportunity to get some swag towards the end of the event. So make sure, stay tuned on the different things we can do to get the swag. Apart from that, just a quick reminder that audience questions are accepted in chat. So I see people are joining us from different places. Welcome, New Jersey, USA. We have people joining us from Singapore. Hello, Aaron. He's joining us from Twitch from Singapore. So as people are streaming in right now, I will go ahead and introduce our guest for today. Our guest for today is a pretty cool dude. His name is Marc, and he will be joining us right now. Marc, how's it going?
Hey, it's Mimi. How's it going? I'm
actually pretty good. Thanks for pointing out that my mic is not working.
Yeah, it was very useful to be able to hear you.
I think that's important. Yes. How's it going, Marc? How are you?
Pretty good. So I'm usually I'm based in Orlando, Florida, but today I'm joining you from a socially distanced vacation in the basement of a friend's house in Salt Lake City. So it's a bit chilly here.
Yeah, I was gonna say it's a bit colder than Florida, right?
Yeah. And you've got your AsyncAPI sweatshirt on. I like it.
Yes.
I've got my Solace Developer Community T-shirt on.
It's all about the swag, Marc. All about the swag. So if anybody is interested to get some swag, as a reminder, you could ask questions, interact, and most importantly, join our Solace community. Join our community. You can see it down below, and we will get in touch with you. We have a lot of cool things on the community. So
yeah, for sure.
Yeah. As we're waiting for people to join our session, Marc, what are we going to be talking about today?
Yeah, for sure. So we ran this workshop at SpringOne back in September, October, and there was a cap of 100 people. So we had, I think, 300 or 400 people sign up for the workshop. So we wanted to give people another opportunity to participate. So we're essentially kind of running round 2 of this. So I'm going to add my screen here. Can you see my screen now? Yeah.
Yeah, I can see your screen.
Yeah. So we're going to be talking about event-driven programming and how it can, basically how you can achieve that using Spring Cloud Stream, which is a framework that we're going to talk about. We'll go over some of the basics of that. And then we're also going to talk about Async API and using the PubSub Plus Event Portal to kind of visualize and really help you manage the whole process, or even like the software development cycle from initial design to operations and continually improving that. Yeah, for your event-driven architecture.
So we have a lot of ground to cover today.
Yes, a lot of ground.
Exciting. So since we have a lot of things to cover, I'll say let's go ahead and start. And again, a reminder to anyone who's joining us right now on YouTube and on Twitch, ask us questions. We are giving out swags to interactive audience. Join us on the community as well. So you can see the site down below on solace.community, and we're also available on Twitter. So follow us on @SolaceDevs. We have a lot of updates and a lot of cool things. So this is going to be a very interactive session. I'm looking forward for it. Mark, go ahead and let us know what the agenda is. Back to you.
Yeah, for sure. So yeah, feel free to add the questions if you're watching on Twitch or if you're watching on YouTube. We'll get those questions and try to answer them in real time. And so, as I just said, we're going to go through some introductions, which I think Tamim and I basically just did that. And then we're going to go into the Spring Cloud Stream basics, and we have a short hands-on tutorial for that, followed by digging more into the event portal and Async API, where we'll start with an existing event-driven architecture, since I think, for most companies and most developers, you're kind of starting with something. So we'll start with something as well, and then extend the architecture and use Async API to kind of enable easy development of some event-driven microservices. And we'll do that as part of a hands-on tutorial. So we'll start with the Spring Cloud Stream basics, and I'm actually going to jump over to our Solace developer code labs for this one. So we have code labs over at codelabs.solace.dev. So these code labs are really hands-on tutorials that kind of provide a step-by-step way of doing something. And so for this workshop in particular, we're going to go ahead and filter by Spring. And we're going to use the Spring Cloud Stream Basics one. So this is always online. So you can, of course, follow along in your own browser during this workshop, during this live coding session. But also afterwards, this is available for you to use whenever you would like. So I'll go ahead and choose Spring Cloud Stream Basics. And so essentially what we're going to do here with this code lab is, first we're going to go over, well, essentially the basics or the fundamentals of Spring Cloud Stream, and then we'll actually create a Cloud Stream processor application that will receive a stream of events, do some minor processing, and publish another stream of events. And we'll also look at using function composition and how that can make like kind of the development of more complex microservices simple to code and to test. And then
zoom in a bit, Mark.
Yes.
There you go. Okay, perfect.
There we go.
Awesome.
Is that better? Yes.
Yeah, that's golden. Yeah.
That's golden. Yes.
Yeah.
So my goal in going through this workshop is for it to be hands-on. So please follow along if you would like. If you just want to read about Spring Cloud Stream, of course, after the workshop, because right now you want to actually do the hands-on part. But the Spring Cloud Stream reference guide, which is linked here, is a great resource that's put together by the Spring team. And this goes through like all of the basics of Spring Cloud Stream. So you can go here for details on error handling and patterns and all that are supported by the framework. There, of course, is a GitHub repository of samples that the Spring team has, and then also one that Solace maintains that uses the Solace binder for Spring Cloud Stream. So if I go next here, essentially what you'll need for the hands-on portion is Java and Maven and your favorite Java IDE. So if you're a Java developer, you likely already have these things. As long as you have Java 8 or newer, you're good. I think in most cases, people are using Java 8 or 11 or 13 at this point. But if you need to install these or check your versions, the commands are here. I'm going to go ahead and use Spring Tool Suite as my IDE, but we're going to be using Maven projects. So basically any Java IDE will work with a Maven project.
What's your favorite theme in this IDE, Mark?
My favorite theme in the IDE?
Yeah, do you get to choose different colored themes, or do you just go for like the basic white theme for it?
I'm a basic guy, so I'm not using the white theme though. You see, I have the dark mode on.
Okay,
yeah. I'm usually working apparently out of basements and stuff, so in very dark places.
Okay, good to know. Noted.
No. And then the next thing you'll need is a messaging service for running through this code lab. So in order to do this, you can head over to Solace Cloud, and so there's a link here to do that. And I'm actually logged in already. No, this is So it'll bring you to this new account page, and you can quickly sign up. And then it will actually walk you through, if you go into messaging services, how to create a new messaging service. So you just hit the plus button and then choose your messaging service type. So go ahead and choose developer. This is all free, and you basically get a free trial account when you sign up. I believe it's free for 60 days at this point.
Right.
And so once you spin this up, it will take a few minutes to start. So I would say, go ahead and get that started now. And then by the time we go to actually use the messaging service, your service should be ready.
Yeah, and a quick reminder, I have the link. You can see it there if you want to try Solace for free and sign up for a free account. Go ahead and check it out. And again, reminder to anyone who's joining us right now, you could ask us questions on the chat window. We can see it as it's coming. And a reminder that if you are interactive with us and active with the questions, you will get the opportunity to get some Solace swag. And don't forget to join the community.
Yeah. For sure. So so just to keep in mind, of course, we have this as a service offering, which is in Solace Cloud. We also have software and hardware appliances, and they are feature function equivalent. So you could use your local Docker container or a broker, other brokers as well. For the second part of the session today, though, we will be using Event Portal, which you'll need a Solace Cloud for if you'd like to follow along for that part. So good to just sign up for the free Solace Cloud account. So it takes a few minutes, and then once your service spins up, it's going to make me log in again. I'll log into my free account. You'll have something that looks like this. And if you go to the Connect tab here under Solace Messaging, this is the connection details that we'll use for today. To connect using Spring Cloud Stream. It actually uses the Spring Cloud Stream wraps JCSMP, which is our Java API, and uses Solace message format, which is SMF. So that's what we're using here is the credentials for Solace messaging. All right. So now that we have our service stood up, or hopefully it's being started up for some of you if you didn't already have one, we'll go ahead and talk about Cloud Stream fundamentals here. And so we're going to start off with the basics. Spring Cloud Stream is essentially a framework for creating highly scalable event-driven microservices. And this is kind of their definition, is by pluggable messaging services. And the reason that they say pluggable is because you can use different event brokers or message brokers as kind of the means of communication between your microservices. And those are made available via what Spring refers to as binders. And we'll talk more about binders in a second. The framework itself is built on top of Spring Boot and Spring integration. So if you've ever developed an app using Spring Boot, it's very similar to that. And every Spring Cloud Stream app is actually also a Spring Boot app. So there are three different types of message exchange contracts. So if we look at the image here, we basically have sources, processors, and sinks. And you can see we have transport binders here that kind of provide an abstraction layer between your microservice and the event broker of your choice. So suppliers or sources here are suppliers or publishers of events. So they publish event streams through the transport binder into your event broker of choice. We then have sinks on the right-hand side, which are consumers or receivers of those event streams. And so they, of course, receive events through the transport binder, and it executes the code within your Spring Cloud Stream app. And then we have the concept of processors, which are a combination of suppliers or sources and sinks. that both receive and publish events. Usually they're receiving a stream of events, doing some sort of processing on that event stream, and then publishing the processed events or related events that are created.
I'll have to say, Mark, one thing that for me, for example, this is the first, like this year was the first time I used Spring Cloud Stream. And one of the things that I really liked about Spring Cloud Stream in general is the abstraction that it does. So regardless what broker you use behind the scenes, the availability of binders, it abstracts the broker-specific APIs where you don't really need to understand, for example, the Kafka APIs or RabbitMQ broker or like a Solace broker APIs. The binder takes that for you, takes care of that for you, and with the idea of abstracting the underlying broker of choice.
Yeah, exactly. So as long as you don't do anything specific to a broker and you just follow the concepts that we're kind of going through in step 3 here, you could, in theory, switch out the Solace binder for the Rabbit binder, and like it just works, or another binder of your choice. And so you can see, you have the event broker of choice. So of course, if you're using Kafka, you would use the Kafka binder. If you're using Solace PubSub Plus, like we're using today, we're going to go ahead and include the Solace binder.
Right.
And so in Spring Cloud Stream version 3, so we're going to keep these message exchange contracts, in mind here of source processors and syncs. And let me zoom out a tiny bit so we can see them at the same time. These kind of map to Java functions that were introduced in Java 8. And so starting in Spring Cloud Stream v3, which is the latest version, they're using kind of this functional programming model. And so a Java util function supplier method is going to be used for source applications, a Java util function consumer for syncs, and a Java util function method for processors. And that, again, that's going to be the one that consumes, processes, and produces events. And I think this will become a little bit clearer in a minute when we develop our first processor app. And then, as we mentioned previously, it's the binders really that provide that magical, the magical, I guess, abstraction layer that allows you to write a messaging or event-driven app or microservice without actually having to learn the API for that message broker. And so right now, when we created this code lab back in September, the binders that are available are Rabbit, Apache Kafka, Amazon Kinesis, Google PubSub, of course, Solace PubSub Plus. We were the first partner maintained binder, actually. Azure Event Hubs, and Apache MQ. So today we're going to use the Solace binder, and it supports the publish, subscribe, and consumer groups communication models. So that's 2 of the 3 communication models defined by the framework. And so the framework actually defines, publish, subscribe, and so this is where your subscribers are independent from each other, and they receive all of the events in order. Of course, because we're using event-driven, they're also decoupled from the publishers. We then have consumer groups because in a lot of times you need to be able to fan out and load balance, across multiple consuming apps in order to keep up with the amount of events that are coming through, or just to spread out your processing among multiple applications. And then the framework also has stateful partitioning support. So this works in a subset of the binders. Obviously, Kafka would be one of these that supports partitioning. So those are the basics. Like I said before, the Spring Cloud Stream reference guide goes into a lot more detail. But if you guys wanted me to just, you guys can walk through that whenever you'd like. I'd like to actually get a little bit hands-on here. So we're going to go ahead and create our first processor. And so there's kind of 2 ways that we can do this. The code lab walks through generating it in the IDE using Spring Initializer, but you can also use the Spring Initializer at start.spring.io. So just to show you guys that, start.spring.io is the web-based Spring Initializer. So you can do things on this site, or you can use the IDE and follow along with the steps of the code lab, which I almost lost. Okay, so I'm going to go ahead and go over to my IDE. And basically, when I say file new Spring Starter project, this actually is using Spring Initializer hosted at start.spring.io. It's just using the APIs behind the scenes. So if you have IntelliJ, or I believe VS Code or Eclipse, you can install the Spring plugin in order to use the Spring initializer straight from your IDE, which is super handy, as you'll see in a minute. So I'm going to go ahead and go to my IDE and say File, New Spring Starter Project. And so you can see it goes to start.spring.io. I'm going to go ahead and call it, we'll call the project SpringOne. And I'm going to go ahead and let it stay with Java version 11. You can, of course, use Java 8 if your system is set up for Java 8. And so if I hit Next here, it's automatically using the latest version of Spring Boot. And then I get to choose which dependencies I would like. So if I type Solace, you'll actually see the 2 dependencies come up that we need. I want Solace PubSub plus messaging, and I want CloudStream. And so Spring Initializer is actually smart enough behind the scenes to say, hey, you have Solace selected and you have CloudStream selected, so I'm also going to include the Spring CloudStream binder for Solace. So that makes it easy, really easy here to get started. So I'm going to go ahead and click Finish on that. And it is importing the project here. I can see at the bottom right. And so it just looks like a, sorry, continue, did you say something?
Sorry, no, I was going to say, like, and as you're going through this, I asked a question to the audience if they ever used if they ever used Spring CloudStream, AsyncAPI, or Solace. Let us know on the chat. And if you could zoom in a bit, someone mentioned it's not, it's pretty small. That would be great. Perfect. Done.
All right, perfect. That's about as that's pretty big. So hopefully,
yeah, no, that's good. That looks good.
All right. Okay. So we've essentially went through these steps, steps 1, 2, 3, and 4, and we now see a project titled SpringOne in our IDE. And so just to point out a few things, if I go over to the POM for us to check out what was actually included here, we'll see the latest Java, well, the Java version that we selected, the latest version of Solace Spring Cloud, which is 1.1.1, and the latest Spring Cloud version. So these are all things that were built up by Spring Initializer for us. And here is the Spring Cloud Starter Stream Solace dependency. And so this is what includes the Spring Cloud Stream binder for Solace for us. So now that we have our application, you can see this just looks like a regular Spring Boot application. You know, there's nothing in my app that says anything about messaging. So the next thing I'm going to do is add a little bit of service connection information. And so this is just to tell the Spring app how to connect to our messaging service. So I'm going to go ahead and copy this into our application.properties file, which is under source main resources. And unfortunately, I can't make this left side bigger. But when I open it here, you should be able to see this. All right. And then what I want to do here is update this with the connection information from the service that we created in Solace Cloud, just so we can exchange messages across our messaging service, essentially. So I'm going to go ahead and go to my messaging service. And so where we looked earlier, right, on this Connect tab, I have my connection details here. So I'm going to go ahead and grab the username, password, message VPN, and SMF host. And so I'm going to go ahead and grab the first one there.
While you're grabbing this, we got a quick question from one of the audience. What is the retention policy when it comes to acknowledgements and NACs, like ACKs and NACs, and expiration when using Spring CloudStream?
I'm sorry. Give me one second here.
Yeah.
Can you repeat the question? I'll listen.
No worries. So the question was about the retention policy. So when it comes to ACKs and NACs and expiration, how is that handled in Spring CloudStream in the binders?
Yeah, so the Solace Spring CloudStream binder, so you'll want to look on a binder by binder basis to see how they handle things. But the Solace binder uses our persistent or guaranteed messaging. So we wrap JCSMP, and when we use guaranteed messaging, that means that every publish. Every message that's published is acknowledged by the broker, so our application knows that the message was received by the broker. And the same thing on the consumer side. When you consume a message from the broker, if the message is processed successfully, by default, it's in auto ACK mode. And if it's processed successfully, it will automatically ACK. Of course, if your consuming code throws an exception, then there's a bunch of like error handling options. So you can have a Spring retry template configured to retry the processing and see if you can make it not fail. Otherwise, it will go to an error channel within the Spring app, and so you can have error handling code. And but it's also knacked back to the broker. There's also the concept of a dead message queue in Spring CloudStream, which is different than the Solace dead message queue. And so you can read more about that in error handling in the Spring CloudStream reference guide and in the Solace binder documentation. So there's like a lot of information there.
Right.
About that. Yeah.
Right. And I hope this answered the question, Vijay. And if you have any further follow-up questions, you can either ask them in the chat or you can join our Solace community where a lot of people ask questions there.
And I will add one more thing there. So from a Solace perspective, the binder enforces our best practices. So it publishes to topics using persistent messages, and it consumes from queues. And so if you're using a consumer group, it uses a durable queue. And if you're consuming just in the publish subscribed pattern, it uses a non-durable queue. But of course, these Solace queues are queue endpoints, and so you can configure, the message time to live. Like you can set it to respect the time to live on messages that are coming in. So just to address his expiration point there. Perfect. All right, so back to our Spring app. Okay, so I now have my connection information in here. I'm going to leave it at connect. Well, just in case I have issues, I'll set these to 1 so they don't retry too long. But back in our application now, you can see our app itself still has nothing in the app that says anything about messaging. And so when we go to our next step here, we've added our messaging service connection information. So now we want to write our Java function. So we have our SpringOne application.java file open. And like I mentioned before, it's a generic Spring Boot application. And we're going to go ahead and write this function here. And so this is a simple uppercase function. And so we import the bean. You can see essentially, so this is a Java util function.function class. It takes in a string and it outputs a string. And so Java util function. My IDE is a little bit slow today. Let me click finish there. Now my errors will all go away. So what we're doing is taking in a string value here, and we're going to uppercase that value and return it. And so again, nothing in here. This is just a generic Spring bean, right? It takes in a string, outputs a string. We don't see a message anywhere, right? But because we have included Spring CloudStream on our path, and it knows about the uppercase function, it should automatically bind that to the binder. So if I actually run this app and just say run Spring Boot app, so that's one way to do it, is in the IDE. If you do not have the IDE with the Spring plugin, then you can use Maven for this. Did I misclick? Run as Spring Boot app. Oh, there we go. I guess I didn't click it before. Or I started 2 of them, maybe. I don't know, we'll find out in a minute. You can see that it starts up, and it actually, if I zoom out a little bit here, it's a little small, a little big. But we can see here that because by default, it will use the publish subscribe scenario. And so it starts up and it creates a producer, producing to the topic uppercase out 0. And so it gets uppercase from our function name, and then saying out for the stuff that's going out of our function, it's going to send the first parameter to uppercase out 0. So that's where the 0 comes from. And then on the input side, it created an anonymous or temporary, which is a non-durable queue, called uppercase in 0. And that's where it expects to receive this string from. So under the covers, the binder and Spring Cloud Stream is actually taking the payload of a message and saying, hey, that's a string, and exposing it just as a string to this method. So we don't have to worry about dealing with the message itself in Spring Cloud Stream. We just say, we process the payload as a string, and we output another string, which Spring Cloud Stream wraps in a message object and passes on to Solace for somebody else to consume. And so I ran it here in the app, but if you're following along in the code lab and you don't have the IDE, what you can also do is just run maven clean spring boot run from the command line. So let me go ahead and do that just to show everybody. I did start it twice. I thought so. So where is this code? So if I go here, I do a maven clean spring boot run. I can also run it from the command line here. Let me switch to Java 11. Now let me do maven clean spring boot run, and I think this should work.
And just a quick reminder to anyone who's joining us right now, if you have any questions, feel free to ask them in the chat window, whether you're joining us from Twitch or YouTube. And let us know where you're joining us from, what city, state, country you're joining us from. I'd be curious to know where people are joining us from, in what parts of the world. And as you can see here, Marc, back to you running the application from terminal.
Yep. So it's now running in the terminal, and essentially now that we have it running, we didn't really do much messaging here. So let's make sure it's actually connected to the broker and working. So in order to do that, we're going to use this actually pretty nifty tool that is available in Solace Cloud. And so if I go to Solace Cloud and I click the try me option here, so again, we are in the messaging service, and then choose try me. We actually have a publisher and a subscriber here that actually uses Solace web messaging. So we're going to send a web message to our Spring Cloud Stream app. By default, it's configured to use your default connection. So you can go ahead and connect the publisher and the subscriber. And as we saw earlier, by default, we're publishing to uppercase out 0. Our Spring Cloud function is. Our Spring Cloud Stream app. And so if I subscribe to that, and then I publish to uppercase in 0, and we'll say, hello, if I can type, hello to Mimi.
Hey, Marc, how's it going?
Pretty good. And so if I publish that, what I'll actually see here is I received, on the output side, my message completely in uppercase. So what happened here is, I sent this message from this publisher. It was actually sent as a message into Solace on the uppercase in 0 topic. My Spring application over here actually received the message, and it processed it, and it said it was uppercasing it. So if we remember in our code, all we did is say we're uppercasing it and then returned the uppercase string. And that uppercase string went out as a string. Spring Cloud Stream wrapped it in a message, and then on our subscriber side here, we received that. So that's kind of like the first intro here in a Spring Cloud Stream. We developed this event-driven microservice, and what it's like.
And I think that's
5 lines of code.
Marc, that you had no reference to a message in your code. It was all handled in Spring Cloud Stream, and the abstraction layer in there allowed that ability to interact with the broker, abstract the Solace broker specific APIs, and have this back and forth communication, and literally include fundamentals of messaging within your application. So that was a pretty neat way to do it.
And I will say, obviously this is super simple example to get started with. A lot of times your business logic will be probably a lot more process intensive, and you'll have to do more complex things. And so one way to do more complex things is what we talk about here, the next part of the Spring Cloud Stream Basics Code Lab, is function composition. And so this is actually inherited from Spring Cloud Function. So when we're using these Java util functions and suppliers and consumers, we're actually leveraging Spring Cloud Function under the covers. And so what this allows you to do is actually compose multiple functions into kind of a processing chain. So you can have simple functions like our uppercase function or like this reverse function here that stand on their own, and so they're easy, right, to write unit tests for and to potentially reuse for other things. As an example, we're writing a messaging app here, but because this is just a regular Spring Boot app, you could, in theory, reuse these beans for some of your like RESTful applications or other applications, you know, that you're developing. And so we can add this reverse method as a second method. And so now we have an uppercase and we have a reverse. So now that we have multiple methods here, we kind of have to tell Spring Cloud Stream what we want to do with them. Do we want them bound separately? Do we want uppercase to be run before reverse or vice versa? And so in order to do that, we can actually configure in our application.properties file what we want there. So I'm going to go ahead and copy from the code lab here, and we'll slap this over here. And so what you could do is actually define the functions that you want exposed to Spring Cloud Stream, well, Spring Cloud Function. And so you can use the pipe symbol here to actually combine them into like a pipeline. I guess that's probably why they use the pipe. So we're going to say, hey, uppercase, like process the message that comes in using the uppercase function and then the reverse function. So it will come in from the broker into our Spring app. It will pass through the uppercase function and then the reverse function. So it does not go back to the broker in between. It's just passing from one method in your Spring app to another method. And then we actually bind that to the broker how we would like to. So in this case, by default, it would use uppercase reverse in 0 and uppercase reverse out 0. Obviously, that's starting to get a little bit complex. So you can actually name the input and the output, what you want your topic to be on the way in and the topic on the way out. So I just named them input and output to keep it simple here. So let's go ahead and restart the app, and then we'll test it out just to see what's going on. So
that's pretty neat. So all you have to do is just add the pipeline, the pipe character, and then your message would go through as many functions you have defined in your pipe.
Yeah, and so here I am, defining them together as a pipeline. You could also define them as separate bindings if you wanted to listen on one queue or topic to do uppercasing and a different one to do reversing.
Right.
So I'm going ahead and running this from the command line again, since a lot of people probably don't have the Spring IDE. And so now if I go back to the Try Me app, I'll go ahead and clear the message from before and clear this. I want to listen on the output topic, and I want to publish to the input topic. And we'll say hello to Mimi again. And if I publish this, I now see that my string has been uppercased and reversed. And if I look back at my app here that's running, you can see that I uppercased it first and reversed it. So this is what we expected to happen. I'll bring that up on the screen a little bit. All right. Tamimi, did we have any questions or anything?
Yeah, so we had a question just in general. It's somehow related to Spring Cloud. The question was about if we have two Solace brokers and they're on cloud, the load is distributed between the service if we're using two different brokers, and how is the message ordering guaranteed while consuming? So the question is more if we have like
two servers. So you're talking about when you say Solace servers, Vijay, are you referring to two different Solace event brokers? So I guess that's a question there.
Yeah.
So message ordering, I'll tackle the message ordering part. So in Spring Cloud Stream, because it is using publish subscribe, the publish subscribe pattern, if you don't say you're using a consumer group. So if you don't say you're using a consumer group, then by default it creates a temporary queue, which is an exclusive queue. So when you come up and you bind to that exclusive queue, you receive all the messages in the order that they are published. So order is guaranteed when you use the publish subscribe scenario where you're not using a consumer group. If you use a consumer group, it creates a non-exclusive queue. And so with a non-exclusive queue, if I had 5 instances of my app, they all connect and they'll receive the messages in a load balancer, like a round robin type setup. So, instance 1 would process the first message, instance 2 would process the second message, etc. Of course, the challenge there is if those messages come like right after each other, we're talking like microseconds apart or something, of course, message 2 could finish processing before message 1. So there are scenarios there where you want to make sure that ordering is not as important if you're using the consumer group. Or, of course, from a Solace perspective, you could set up your topic hierarchy in a way that is you effectively kind of partition your messages or hash your message streams coming in. So you can say, like, for example, application 1 is going to listen on one consumer group, which will always process, like, I don't know, stock trades for Apple, because you always want like one app to process Apple ones, and a second one to process like stock trades from Google, for example, or all the stock symbols that start with G, for example. So that's like using the Solace topic hierarchies, you can kind of easily filter what events you want to make sure that the events you actually care about are in order. So one common use case for that, besides like stock symbols, is like an order ID. You could filter on specific order IDs to where that in the same application that gets like an order is placed would get like an order updated or an order canceled event to make sure that you don't get the canceled event before the order created event, for example. Right. So there's things that can be done for ordering there.
I hope that answered your question, Vijay. If you have any follow-up, please feel free to ask. Another question, Marc, it's about data transformation and handling the payload. So if we need to transform any data in the event payload, where do you recommend that we do the transformation? And that's actually a good question that kind of highlights what the event broker does and where you could do actually payload transformation.
Yeah. So I think for most people now in event-driven architectures is you kind of want to have dumb pipes and smart endpoints. And so our smart endpoints would actually be like our Spring CloudStream apps themselves. And so you would actually do your message validation or transformations or things like that in your actual code. And then you pass the payload across an event broker, and the event brokers themselves would be kind of agnostic to the payload of the messages.
Right.
So that said, one cool thing that could be done with this function composition that we were just looking at actually is, imagine that instead of uppercase and reverse, you kind of were receiving events like from, maybe it's like an industry standard event, right? And so you get an industry standard format in, and internally you have your own object model. What you could do is have generic functions that do validation of that domain object model, and then maybe you'll validate it in one method and pass it to a different method in your processing chain that will convert it to your internal object model before actually passing it to another function that would actually do the processing, right? And the same way on the way out. And so then you can effectively create a processing chain that basically takes in a domain object model, validates it with one method, converts it to your internal one, processes the internal event, and then on the way out maybe converts it back to the domain object model before publishing it out back to other consumers that know only how to read the domain object model.
Right.
So really doing the transformation within your app.
Right, and this is here what I wanted to say as well. This is where you can leverage your topic hierarchy, where you can be very detailed in your topic hierarchy, and you could add another level of granularity in your topic hierarchy, and you publish events on different topics. One of the topic would be your transformed event payload, where you do the transformation within on the client side and publish it onto another topic. So. Yeah. Hopefully this answers the question, Danish. And while we're in the topic of schemas and payload transformation. A question was there about, is there any schema validation? If yes, where? And I'm assuming this is kind of like along the same line of data transformation, or if you want to do anything with data transformation, payload handling, adding things to the payload, or even validating the schema of your payload, that could be done within the on the client side.
So you could do it on the client side. So Spring Cloud Stream itself, like so far we're looking at a simple example here where we take in a string and output a string. But there's no reason this has to be a string. This can be a POJO, and we'll see that in the next code lab. And so what Spring Cloud Stream will do is it has default message serializers and deserializers to know how to convert from like JSON, and I believe there's an XML one. So this is in the Spring Cloud Stream reference guide. And so if it can figure out with one of its message serializers or deserializers how to convert that to your POJO, it will do that for you. So obviously that would be the scenario where it's valid. If it's invalid, it wouldn't know how to convert that, and it would end up in the error channel, I believe.
Right.
So in the next code lab, we'll look at using a POJO as one of our arguments for our functions.
And that's a very interesting question about like schema validation in particular, because when it comes to validating your schema, there's so many ways you can do it, and there's so many points during your application development where you can do schema validation. And I'll touch base on that once we talk about AsyncAPI and our event portal, where you can design your application and define your schema payload, where you define the schema for your payload, and then you could use other AsyncAPI open source tools, to one of which is including schema validation, and I'll touch on that in a bit. So as we're going through, keep your questions going. Thanks for everyone who's asking questions. This is great. Make it active and interactive. If you have any questions, again, feel free to put it in the chat below. Let us know where you're joining us from. Some people are joining us from Texas. Welcome on to our event, which is great. So let us know as well where you're joining us from. That will be great. And as I mentioned earlier, feel free to join our Solace community on solace.community and ask us question either in the chat or on the community, and you will be given the chance to win some swag with us if you're active and asking questions. As we continue explaining different things on Spring Cloud, the event portal, and AsyncAPI, let us know in the chat, what are your use cases? Is this the first time you've used Spring Cloud before? Have you used AsyncAPI or Solace in general? What are your experiences and interactions with those tools? As we continue, we'll be touching on these. So the first question was about Spring Cloud Stream, that Marc went over and explained the basics of Spring Cloud Stream and how you can use it in an abstracted way to abstract whatever broker you use beneath the hood. And that was kind of the first part of it. I'll give it back to you, Marc, and open it up as well to the floor if anybody has questions as you continue with your slides.
Yeah, so effectively we went through the first hands-on part, which was the Spring Cloud Stream basics code lab here. And just a reminder, if you joined us late, you can find the code lab on codelabs.solace.dev. So it's available after the workshop as well. Mm-hmm. If you filter on Spring here, the Spring Cloud Stream basics one is the one that we went through first. And so that's available here. And so what we're also going to do is, because the session is focused on the Spring Cloud Stream basics, but we also want to go a little bit into architecture and showing how AsyncAPI can help enable a more consistent development of the microservices, of course, also using Spring Cloud Stream. We're going to move on to the next piece here that kind of brings some of that in. So we're going to talk about how an event portal can help with this, and then, of course, use AsyncAPI. So as part of this, Tamimi, I'll let you kind of speak to the next few things here. And I think you're going to do a quick demo, right, of the event portal?
Perfect. Yeah, I'll do a quick rundown on this and a demo. So before I get started, Marc, I just want to kind of point out, if anybody has used a REST API before, or just is familiar with the ideas or using REST APIs, you're familiar with the concept of an API portal. right? So just in general, an API portal for REST APIs. There's a lot of tools, a lot of resources for API portals where you can use it for documentation. You could use it even for code generation. There's a lot of things you can do from an API portal for REST APIs. With the same concept in mind, for asynchronous APIs that are not REST APIs, there's also we also have the idea of an event portal. Through this event portal, you can design, develop, and manage any of your asynchronous APIs. Even during runtime, regardless what broker you're using, you could have different management and different things you can do with your asynchronous APIs. So this slide's kind of like shows you, it gives you a high-level overview on what you can do with an event portal. And keep in mind that the idea of an event portal, the whole point behind it is to manage your asynchronous APIs. And then we'll show you how, using the Solace Event Portal, you can also design your architecture, your event-driven architecture, and develop using AsyncAPI and extracting AsyncAPI specification for your event-driven architecture. Let's go to the second slide. Marc, please. So as I mentioned earlier, when I talked about REST APIs, you might be familiar with open APIs or Swagger, where they are basically machine-readable specification that define your REST API. AsyncAPI is similar to that, but it's for your asynchronous APIs. So if you need a machine-readable application specification that defines your API, and you can see an example on the right-hand side on the slides that it explains your API that could be used to either generate application, auto-generate documentations, which will enable the collaboration between different developers on your team or different parts of your team. So this is where AsyncAPI could be helpful. We'll go to the next slide, Marc. So this slide basically compares, as I mentioned earlier, the comparison between having a REST API. So for your REST APIs, you could have an API management, which is kind of, you could consider it as your API portal. Your specification is defined using OpenAPI. You could generate some code using Swagger, and then you could use that. So this end-to-end process of how you can specify and generate an application for your REST API, it could be done similarly with asynchronous applications. So we'll go to the next this. So for your asynchronous APIs, you have an event portal that defines your API. You'll generate a specification using AsyncAPI, and also AsyncAPI is an open source, has a bunch of open source tools where you can, one of the open source tools is a generator, where you can use it to generate applications using different programming languages that are supported with the generator, which we'll touch base on this further. And then you can use that for during like any runtime protocol, whether it's an open standard protocol like AMQP, MQTT, or stuff that we used earlier that is supported with any asynchronous event-driven protocol. So this slide basically gives you an overview comparison on what you can do with a REST-driven API and how is that similar to an asynchronous API perspective using AsyncAPI to generate specifications and generate code.
Yeah, and I would also add that this here on the bottom, kind of simulating what you can do with an event portal and having that machine readable specification and doing code generation and building a Spring Cloud Stream app, because there is a Spring Cloud Stream template for AsyncAPI, is what we're about to do in the next hands-on section, which is why we're sharing this slide. Is we learned about Spring Cloud Stream basics. We're now going to show how it can be even easier to and more consistent, really, to develop your Spring Cloud Stream apps.
Right. And I know Ramneek previously asked a question about schema and payload schema and where does this fit in your application development. This will be a good opportunity. I'll show you how, where in your overall, if you step back and take a bird's eye view on your architecture, on your overall end-to-end architecture, from a design step, from a design phase where you design your microservices, define your schemas and the payloads, this is where things could go. we'll go to the next slide, and I'll answer some of the questions that we have. So I mentioned previously we have an event portal. The foundational elements of the event portal that we have, and I will give you a quick demo about this. We have something that's called an application domain that defines, your overall architecture. Let's say that you are a ride-share company, and this will be your main application domain. And your application domain is composed, like any application is composed of different microservices. So you could think of this as application. Every microservices could be a publisher and or a subscriber. Every microservice or every application will have events. So these events, you can either publish to events, subscribe to events. Every event has specific metadata, including the topic hierarchy or the payload schema that is available with every event. And in the payload schema, you define how your event, like what is the payload of that is associated with your event. And there's different payload schemas that is supported with the PubSub Plus event portal, including JSON, text, binary, XML, and Avro. And I believe, like as we progress more on the roadmap, the supported schemas as well will all be in the event portal. We have one question coming, which is, let me see this. AsyncAPI is a great piece of documentation, but doesn't seem to have technical implications in the broker. How can validation of a message body against a schema happen in the broker at runtime? So for this one, we discussed, and we'll see what kind of other information we can put in this. We discussed earlier when it comes to validation. Marc brought up a good point earlier about, the goal is to have dumb pipelines and clever applications where, your pipeline, which is the broker, to have the main goal of the broker is to stream events. So there's no validation of the message body that happens in the broker at runtime. Well, you can have the validation of your schema on the client side. Marc,
so let me jump in here for a second. So yeah, I think one of the things here, so AsyncAPI is an open source initiative. It's agnostic to any broker, any message format, or any protocol. So I could have a Marc broker that uses a Marc format and a Marc protocol, and that makes it a little bit hard for this open source initiative, right, to actually provide validation, and especially like how you would implement that in specific brokers. So AsyncAPI just defines these things, and it's up to specific brokers or event platforms and specific applications to figure out how to actually, how or if to validate. And so from a Solace perspective, like we don't peek into the payload, and so we're not actually validating the payload within the broker. It's very much right now in the applications themselves that publish or consume the messages. And that is one of the reasons that we contributed the Spring Cloud Stream template, is the whole framework that comes with it makes some of these things easier, and is really it's more simple for a developer that's used to creating RESTful APIs, for example, to get started with event-driven, since it abstracts you from some of the messaging APIs and also allows you to do validation, against an XML schema or against JSON as you would in a RESTful app.
Right. And when it comes to kind of like using AsyncAPI in general, I want to reiterate on the fact that AsyncAPI is open source, and it's an open standard that defines what you can do with your asynchronous APIs. There's so many tools that is offered by AsyncAPI that the community contributes to these tools. One of the tools is a code generator, which we'll show you in a bit. Another tool is a documentation generator that takes it from the specs and generate documents. There are other tools like validators as well. We're not going to touch on it right now, but you can definitely check it out on their AsyncAPI tooling section, where in the validators, there's different tools you can use within AsyncAPI given your spec that you can leverage from. One of them is a validator.
Yeah, and I would also say that AsyncAPI, again, it's an open source initiative, so anybody can join that community and contribute and discuss. So if you have cool ideas for some sort of data validation, or anything for that matter that has to do with AsyncAPI, definitely join that community and discuss it.
Yeah.
There's a Slack group that is super responsive over there. So bring your ideas to the table, and we'll see if we can make them a reality, right? Especially if they can help your organization, but also other organizations.
For sure. That's the beauty of open source in general, and having a community where if anybody comes up with any idea, it's open source and you can contribute. So while we're in the topic of event portals and explained like why an event portal is as important, let me give you a quick tour on the Solace PubSub Plus event portal and how that fits with the end-to-end story of how you can define and design your event-driven architectures. So this is our Solace Cloud console that Marc showed you earlier, how to create event brokers services using the mission control. What I will be jumping on, it's the event portal side and using the event portal to design your architecture. So I'm gonna click on the event portal. I have two application domains. I'm gonna jump into my rideshare application domain. So you can see this application domain is composed of different applications, and these are microservices. So you can see it in this diamond-like shaped icon object, where every one of these is an application. So my rideshare has a billing app application, or a driver application, a driver management application. Every application communicates with the remaining part of the architecture using events. And this is where the shield-like icon represents. It's an event. So if I click on any of those icons, it shows that the billing app publishes an event that's called a customer receipt generated event. And the passenger app subscribes to this event. So if I drill down on that event in particular, you can see that this event is composed of this topic. So the billing app will send events to this particular topic with a schema that is predefined. So all this is done on a design phase where the architect and the designer designing the application will go ahead and define the topic hierarchy structure, different applications and different microservices, and what is the payload schema that is associated with each event.
Yeah, and I think there's one cool thing to point out here is that, before Solace released the event portal, there wasn't really a great way out there to really visualize your event-driven architecture. So like when Tamimi's showing this graph view, it really allows you to see which event-driven applications you have and which events they're publishing or consuming, to really understand the architecture that is actually deployed in your environment, right? I think, one of the benefits of event-driven is the application decoupling, right? Like your publisher is publishing to an event broker. It doesn't know or frankly care which applications are consuming those events, and vice versa. A consumer or a subscriber is subscribing to certain events and doesn't care necessarily who is or which application is publishing it. And so while that is beneficial because it's easy to extend your architecture and bring new applications online that use those events, it does make it more challenging to really understand what is going on in your operational system. So right. I know, like, before I worked for Solace, I've been here about 1.5 years, but before I worked for Solace, I worked with a bunch of different US federal agencies, and I was actually a Solace customer dating back to about 2012. And so we had an event-driven architecture for a weather satellite ground system, and we had hundreds of events, if not thousands of events, kind of flowing through the ground system. And we had kind of the applications defined in design documentation, so picture like Microsoft Word documents. Mm-hmm. We had spreadsheets of the events, and we had schemas in source control. So all these things in different places, which made it hard for the architect to really have one place to go to understand everything that was going on, and right. Also hard for a developer to follow and really keep up to date when you have all those things in different locations. So with the event portal now, you can define all these things in one place, and you have incentive to keep them up to date because what Tamimi is going to show next. So
yeah, so that's a great gateway, Mark. Thanks for that. And to reiterate on what Mark said, the event portal is a one-stop shop to visualize, design your event-driven architecture. You can even catalog and include, you can like use it for collaboration for different team members. So what I'm showing now, let's say this is like, I would say this is a relatively simplistic architecture for an application. Let's say if you have a more complicated architecture with a lot more applications and a lot more, like thousands and thousands of events, we have the next service within the event portal, which you can see here is called the catalog. And in the catalog, it's again, another one-stop shop where it has all the different events in your application domain. You can have all the schemas that you predefined in here and all the different applications. So let's say the nice thing about this is I am able to search my events. If I want to search for a particular ride event, I can go ahead and search. And here it's showing me all the different events that are related to a ride. So if I want to define or design a new microservice that I want to see what are the different events that are related to rides, whether it's ride requested, ride accepted. And let's say I want to create an analytics microservice that listens to or subscribes to everything related to rides. You can go ahead and search it here. The nice thing about this as well, you could search in your schema. Let's say right now I want to have another microservice that kind of that detects any price surges. So if I look for charge, I want to see what event has a charge in its payload schema. I can see that the ride receipt, if I dig deep into it and I see all the schema in there, there is a total charge and a charge adjustments in this schema. So now I know as a designer and an architect and a developer, what are the events that I need to handle that are related to anything with a charge. So I can go ahead and say that this particular event, the customer receipt generated event, will have a payload information that is related to charge. And that's also like another thing you can do with the catalog.
Yeah, and so that's cool because when you have your system already running, in production, these events are already flowing across your event broker. You can, come in and extend your architecture easily by saying, hey, that event's already available. I could just consume that event, and it already has the information in the event that I need. So again, the decoupling of an event-driven architecture, we didn't have to change the publisher because the event's already available. We can just come online as another consumer and consume that event and process it to extend kind of what our business needs or our organization needs as kind of changes or enhancements arise. Right.
Yeah, so as a developer now, I know if I subscribe to this particular topic, I'm sure that I will receive events that have a charge related property within the so yeah, exactly. So one of the comments we've had on YouTube that this allows us to search the schema. As Mark mentioned earlier, previously, like what other organizations would be doing, they would have the whole design like this, like the visualization of the architecture in let's say Visio diagrams, and then there you will have your schemas defined in source control, and then your events in Excel sheets. So you have them all separated in different places. What the event portal does is a one-stop shop that you can use to design your end-to-end event-driven architecture. You can catalog your event-driven architecture with either events, schemas, and applications. And the third nice thing about the event portal is the discovery option in it. So once I go to the discovery, what this allows us to do, you can scan your event-driven architecture for all the flowing events in real time and get an idea on what's happening in your EDA. So right now we have a supported broker, Kafka. So let's say you have an event-driven architecture where with Kafka brokers in your EDA, you can run a discovery scan, and then you can get an idea, a snapshot on what are the topics, what are the schemas, what is the events that is handled, that is flowing through your system, and we're all like architecture. And on our roadmap, we're going to be supporting different types of brokers. Solace broker is coming up next. So this is even, this makes things even a lot more interesting. Let's say that you have an event-driven architecture with a polyglot of brokers. You have Kafka brokers, you have the Solace brokers, and you want to take a scan snapshot of your event-driven architecture and see what are the events that is flowing, what are the schemas for these events. You can run a scan and then upload upload the scan into your event portal, and from there you can contribute back to your designer. So that's also another thing that you can do with the event portal that I wanted to highlight in the discovery.
Yeah, and so Tamimi, actually, I think we just released a brand new code lab for that, right? So if you actually have a Kafka broker and you want to test out the discovery and import it into the event portal, you can go to this code lab and it will walk you through how to do that. And actually, if you don't even have a broker, it also provides you with a scan file that you can just simulate and pretend like you have a broker and import that scan file.
Right.
So this is pretty nifty. I think we just released this like yesterday or the day before. So this is a brand new code lab that you can try that out.
Yeah,
and,
so to go check it out. And if you have any questions, like we're not going to dig deep into this right now. We have other resources. We have other videos on our YouTube channel that you can check out that talks about that particular feature of the event portal. But if you've used it, or if you have any feedback, or you want to share your experience with Solace Broker, or the discovery scan, feel free to join the community and put your questions into the community. If you're interactive and you're asking questions with us, you'll get the opportunity to win some swag. Yeah, so this is what I really wanted to highlight and show you from the event portal perspective. And again, this is free to use on if you sign up for your Solace Cloud account.
Yeah. And so, yeah, for those of you that just signed up for the Solace Cloud account as part of the first code lab, you have that available to you. And again, it's a free trial for 60 days. So it's not like we're turning it off like right after this workshop or anything. So you can check that out. And then also, we're now going to move on to the next hands-on part. So we wanted Tamimi to give you a quick demo of the event portal, because we're now going to use it as part of our next code lab. So we're going to do design to code. So kind of like most developers would, right? We'll work with our architects to come up with a design, and then we'll export an async API document and generate some code as part of this. So if I go ahead and click on this.
And you could like follow along with us as well if you want to ask questions, or you could just stick around and see this. We have a question to ask: is this an open source tool, the event portal? Right now, you could sign up and get a free a trial account. Down the road, there are talks about these kind of things, but I'm not gonna talk more about this right now. If you want to comment on anything,
So I'll touch on it a little bit. So the event portal itself is not open source at this time. Of course, everything that is async API related, like the specification and the code generators that we're about to use as part of this workshop, is open source. Also, we are going to be open sourcing the discovery agent. So initially we have the Kafka broker that you can discover against. We're currently implementing discovery for Solace brokers, which I believe should be available the end of November, but definitely by the end of the year, I believe. But if you were using a different broker like ActiveMQ or Rabbit or IBM MQ, the reason we're open sourcing the agent framework is so you could create a scan for the other brokers, and that way organizations that have multiple brokers, so if you have a TIBCO EMS and an IBM MQ and a Solace PubSub Plus and a Kafka, you can kind of bring in your events and bring in your design onto one place. So the event portal, you don't have to be using the Solace broker in order to use the event portal. It works with any one broker or multiple brokers.
Right.
So
another question we had before we jump in. This seems
cool.
Pull from the broker to the portal, or if you have like a list of brokers and you want to do a discovery scan, how about pushing from the portal to the broker, considering the design starts at the portal?
Yes. So definitely on the roadmap, that is a really cool feature. So initially we are starting with the you had to be able to import what already exists in your production environments into the portal to really see your architecture. We are going to be adding enhancements. So like you could define, as you define your architecture and your security and access controls and things like that, your Q endpoints in the designer, that you could actually roll those out into your runtime environment. Of course, again, you can't have multiple brokers. I believe for that, we're initially going to start with the Solace broker, of course, since most of the Solace customers now are using the Solace broker, and that's what they're interested in. Eventually, over time, I believe we might extend that, but we don't have like a hard roadmap on supporting specific brokers for that. But we're going to go through the design to code right now, so you can definitely take your design and apply that design against your code or the applications that you're building using AsyncAPI. So I think we're going to show that a little bit more here. So I'm going to go on to the second hands-on part of this. It looks like we're at 11:17 now. Sorry, 1:17 Eastern time. So about 43 minutes left. I'm fine going a little bit over that if we have a lot of questions and things. But again, this is a code lab available on codelabs.solace.dev. So anybody can find this and do it on their own after the fact. You can see my screen, right?
Yeah. Yes.
Okay.
Yes.
Okay. So we're going to be using the Solace Event Portal to actually extend an existing design, since I think most people already have something deployed. They're not starting from scratch. And then we're going to be learning about the AsyncAPI initiative and use the generators there to make our life a little bit simpler. And we'll develop an event-driven microservices service that uses Spring Cloud Stream. So a use case overview. So for the rest of the session, we're all going to pretend like we work for a fictional company called New York City Modern Taxi Co. And so we're in New York and we have taxis going around New York. But you know what? We haven't really had the best experience, and quite frankly, Lyft and Uber have eaten our lunch, and everybody is now using those services. So we want to kind of revitalize our organization. We rebranded to be modern, and we want to provide a better experience. So as part of that, we're adopting an event-driven architecture to allow us to receive events in real time and really react to those as they occur. So we don't want to just throw stuff in a database and process it once a day at 3 a.m. because, hey, that doesn't do any good. We're in 2020. I want, when an event occurs, I want to process it, a few seconds later and take action to provide a better customer experience, just like most organizations are doing today. I order a package on Amazon. I expect to get that package as soon as possible. Or, when I travel, for example, if my flight changes gates, I want to know what gate I have to go to before I actually get to the gate and they say, oh, your plane's not here. It's at gate D7, which is like a 40-minute walk away.
I want to say like a good example that I had with this. So Uber, speaking of Uber, they have a cool feature where you can connect your Spotify account to your Uber account. And when you order Ubers, if the Uber driver has this integration as well in their car, your Spotify recommendations will come into the Uber driver's Spotify account, and it will play your favorite music. So this is another example of like showing how in real time you're connecting the user preferences and giving them a very highly customizable experience and highly customizable thing within this. So that's actually a very cool feature that I wanted to say is like, hey, you could still have your references of music within your Uber driver.
Hey, we work for New York City Modern Taxi Co. Stop promoting Uber. No, I was kidding. we can build that in.
We'll add your food preference in there. If you're vegetarian, we'll be like giving you some
So to start this off, we've already enabled our taxi fleet to stream real-time events. And so these real-time events include information about the current ride and location. And so what we really want to do is we want to start like consuming these streams of events that are being output by our taxis and doing some analytics on them. So to start, as part of this code lab, we're going to create a ride drop-off processor that receives events that are specifically geared towards the completion of the ride, the drop-off. And we're going to calculate, do some calculations on them, calculate some averages, and republish those to be consumed by a separate application. And so that will have information like the average number of passengers across the rides in a given window, the average cost of the rides, et cetera. And that will allow us to do some other analytics and improve our experience. And so the events being published from the taxis are actually published on a dynamic topic hierarchy over Solace. So if you've used Solace before, you probably know we have the concept of topics, and we say you should publish to topics and subscribe to queues if you're using persistent or guaranteed messaging. So by publishing to a topic here, like we're publishing to taxi NYC ops ride updated V1, and then below that, these are all dynamic levels. And so we have ride status, so this could be en route, this could be pickup, this could be drop off. We have a driver ID, we have a passenger ID, and these of course are unique per driver and per passenger. And then we have latitude and longitude. So by adding these things into the topic, it allows the consumer to make a very specific subscription to filter on exactly the events that they want. So maybe they only want to filter, in our case, on drop-off events, but also by having like latitude and longitude, you can filter by location of the taxis and maybe show taxis on a map, for example. So we're going to take advantage of that by filtering on the events we want. We only want the drop-off events. So by filtering on that, we'll only get the events that are drop-offs, and we won't receive the events that are like en route or pickup events. So we're not receiving like thousands of events and throwing 90% of them on the floor. We're only actually going to receive the drop-off events, which is a really cool function of or result of using topic hierarchies within Solace. So in order to actually implement this, we have the what you'll need section here. And so we'll install the AsyncAPI generator in a few minutes. But in order to do that, you need Node.js and NPM. You can check the versions here. And if you don't have them installed, the installation instructions are available at this link, which brings you to AsyncAPI. Spring Cloud Stream, if you did the first part of this session, you already have this installed, Java and Maven and a Java IDE. Broker connection information. So in this case, we're actually going to use a publicly available event feed. So we have the credentials here. So this way you can actually receive real taxi data, and we can do more than just like sending a message using the Try Me tab for this. So that's pretty fun to have a real simulated feed of data that we can use. And then, of course, we need the PubSub Plus Event Portal. So if you already signed up for a Solace Cloud account, of course, you can use that. If you haven't yet, go ahead and click this link or the link that's scrolling on the bottom of the screen. You can go ahead and type that in and sign up for a free trial account, which is good for 60 days. And the next thing we're going to do is import the application domain. So go ahead and get signed up if you haven't already. I'm going to go ahead and go on to the next step here. So I'm going to log into my account. Let me delete this real quick. Let's delete. So I have no application domains here. And so what I'm actually going to do is grab this import file. And so let me go ahead and go over my terminal, kill my app that was running. And I'll go to dev temp SpringOne repeat. I've got an empty directory here. And so I'm going to use this directory for this workshop. So this just grabs a JSON file from GitHub that is essentially the export of New York City Modern Taxi Company. So like most organizations, right, we already have stuff that exists. So we're going to import this file into the portal and start using that. So I'm going to click import at the top right and choose import. And where did I put that? Dev temp SpringOne repeat. Choose the JSON file. New York City Modern Taxi Co. is now back. And if I go in here, I see I have taxis and I have my taxi status update. So back to our diagram for a second in our use case, we have this initial piece here. We have the taxis publishing their ride update information to the event mesh, and we're going to develop these other pieces here. So before we develop it, we of course want to design it. So let me see, the end of what you'll need is what we just did, we imported. And so the next step, of course, is to design, or in this case, extend our event-driven architecture. So we go into the designer in the portal, and we're going to go ahead and add the drop-off processor application. So let me see if I can keep these steps side by side, actually. So I go there, and then I go here. Maybe this will work. We'll find out. All right, so to add this application, I'm going to go ahead and say create application, and I'm going to create the ride drop-off processor. And we'll go ahead and add our description. And the application class right now is unspecified. The other options are Kafka application or Kafka connector. We'll be adding more application classes, as we go on, as the portal gets updated. Essentially, if you are actually signed up for the portal, you'll notice, week after week, I think it's every Thursday, we usually push out updates. So because it's a software as a service, you can get enhancements without actually having to do updates and stuff yourself, which is pretty cool. I'm going to add myself as the owner of this. And then we also have the concept of tags. So tags allow you to tag applications and events to allow for ease of filtering in the portal. So in this case, I'm just going to add SCSt, which stands for Spring Cloud Stream, just so this kind of says like the type of application, or in this case, the framework I'm going to use to develop this app. But you could have tags for different use cases or anything that you would like to filter on. I'm then going to click Manage here and choose which events that I would like to subscribe to. So in this case, I have my taxi status update event. I would like to subscribe to that. And I'm going to go ahead and click Save. And so I see my ride drop-off processor is now showing up. And this is the application that we're going to develop next. Well, first as part of this. So we see it on our graph. And now we need to add the next event, though, because if we remember in our architecture here, our ride drop-off processor is going to receive the ride updated events, and it's going to publish a new event that is like a stats drop-off event. So we need to add that stats drop-off event, or sorry, ride average update event. So it includes stats about the drop-off. So I'm going to go ahead and click Create Event. So I'm right-clicking, by the way, on the graph, and I can choose Create Event. And so I want to call it Ride Average Update, and then add a quick description. So this event is going to include the average cost of rides. It also includes the average number of passengers, et cetera, over a specified duration. So what this application is going to do is it's going to subscribe to drop-off events. We're going to specify a window. We'll go ahead and use 20 seconds for the window, just so we can keep it moving along. And so every 20 seconds, it will say, hey, I got these 3 drop-offs. Let me aggregate the averages and publish those out as a new event that can be consumed by other applications. For the topic scheme, I'm going to go ahead and choose Solace. And so this is the same for AsyncAPI and REST and SMF. Just a side note here, we do have a topic best practices guidelines guide that will kind of go in depth and give you ideas for how to design a topic hierarchy that will be useful for your organization. So I'm going to go ahead and add a Solace topic here from the code lab. And so again, you can see we're using a hierarchy here that will allow us to filter on the specific events that we want. And then I'll go ahead and add an owner. Again, I'll go ahead and make myself the owner since I'm in my own personal account. I'm the only user right now. But of course, you can make other people owners within your organization. So now we want to define an actual payload schema here, though. So for the value of the payload, I'm going to go ahead and click Add New. You can make it a primitive type. So if you wanted it just to be a Boolean or a float or string or something, you could do that. But we're going to use an actual JSON schema. So I'm going to go ahead and click Add New. And I'm going to define the payload as the ride average payload. We're using JSON. And I'll go ahead and make myself the owner again. But what I really want to do is, we'll throw a description too since it's in the code lab. I want to define my, I'm basically going to use JSON schema to define what should be in the payload. And so I've already generated this using JSON-schema.net, but I'm going to go ahead and copy it from the code lab into the content window here. I'll make this a little bit bigger for a second so we can see it. So on the right-hand side, the portal gives us a sample message of what it would look like. So I can see I'm going to have a ride ID, which one enhancement that's on the roadmap is actually using the real samples from the schema, but the ride ID would be a UUID and other information in here about maybe where the message is being published from, the latitude and longitude, and information about the driver as a driver object as part of this and a passenger object as part of this. So this is a real use case for a schema, so it's not just a super simple schema here. I'll go ahead and click Save. And automatically now it brought us back to our event and added the schema in there for us. So if I go ahead and save that now, I've created my event, and the next step in the code lab actually is, hey, we have our event created, but now we need to add it to our application. So our ride drop-off processor here, if we go to Manage Events, so again, right-clicking on the application and Managing Events, I can now say, go ahead and publish that new event we just created, and click Save. And our architecture is now updated to say the ride drop-off processor consumes taxi status update events and publishes ride average update events. And so we just extended our architecture. So Mimi, do we have any questions or anything before I go to the next step?
I wanted to use this as a segue to ask the question that we have. So this next question is kind of, I wanted to emphasize on like conventions and the terminologies. So the question is about like, is the topic defined on this page a durable topic or not? And I wanted you to touch base on the difference between a topic and a queue on that perspective, Marc. And
yeah. So oh, I get an
ahead.
Echo. Oh, okay, better. All right, so this is not, so when we define, in the world of Solace, when we define a topic here, this is actually, when you publish to a topic in Solace, it's really just a header or metadata on the message itself. So publishing to a topic is just logical, and then the Solace broker itself looks at that and routes the messages based on that logical header to subscriptions or endpoints, basically two things that are subscribed to that logical topic. So we have the logical topic on the publishing side, and then on the consuming side, we have the concept of endpoints. And so usually in most cases, we recommend you use a queue endpoint. And a queue endpoint can subscribe to one or many topics using specific topics or topic wildcards. There also is a topic endpoint. The queue endpoints have more functionality, so we usually recommend you don't use topic endpoints. There's a few uses for them. I think it's with like, so if you're using JMS and you want to use selectors, I believe there's restrictions there. And so if you're using JMS and you want to use selectors, you can use topic endpoints for that. But for the most use cases, like 95% of the use cases, use a queue endpoint with topic subscriptions on it. And so what happens then is we publish a message and we publish it to this topic. The broker says, hey, is there any subscriptions that are listening for events that arrive on this topic? Yes, I have application 1 over here, or in this case, we're going to have ride drop-off processor that's subscribed to taxi status updates. And so it routes them to the endpoint that my application is listening on. So if I'm using a queue endpoint, the message will be attracted to that queue and then delivered in order to my applications consuming from that queue. And that's the guaranteed or guaranteed or persistent messaging use case. If you are using direct messaging, which is our non-guaranteed quality of service, then your application can actually make topic subscriptions. And so it subscribes to certain topics that are not actually endpoints created on the machine. It just says, hey, I'm interested in these events that maybe arrive on certain topics, one of which could be this topic, could also be multiple. And then those are routed to that application while it's online. So hopefully that answers that question.
Perfect. And a follow-up question on this. We have a question on Twitch. Cool Dev Ninja said, "This is so cool. Can I have multiple queues subscribing to the same topic?"
Yes. So our product name is PubSub Plus, and so one of the reasons for it, I mean, one of the main reasons, right, is we follow the paradigm of publish subscribe. So publish once, and you can publish an event from one application or from multiple applications, and that event goes out on that topic. And then you could have one, you could have two, you could have 500 applications trying to consume that same event. So there could be multiple instances of a certain application. They could be completely different applications, right? That as long as you say, I want to subscribe to a certain topic, then you get that event.
Right. Okay, perfect. Thanks, Marc.
All right. And so the next step in the code lab here, so we've now designed our event-driven architecture, but we want to develop this ride drop-off processor. And we want to use Spring Cloud Stream for that. But we just defined all of our channels. And so we know about our topics that we're going to consume from and that we're going to publish to. We know about the event, and we know about the schema that defines the event payload. So like, can't we make that easier? Like, sure, as a developer, I could go read all that in the portal and I could go code my app. But this is where AsyncAPI comes in. And so we're going to go ahead and install the AsyncAPI generator. So if we just run this command on the command line.
And a quick note that anybody, you could go on AsyncAPI's website and look at the tools. The generator is one of the many tools that that AsyncAPI has to offer. There are other tools as well that is supported by AsyncAPI. And Marc, while you're doing this, we have another question that talks about, is there a use case when you should go with topic endpoints instead of queues endpoints?
Yeah, so first let me point out, if you are installing AsyncAPI generator, or you have before, for this workshop, please install 0531. This is the latest release version of AsyncAPI, at least when I checked a few days ago. If you do not specify the version, it actually gives you like the latest snapshot release or working release. And so sometimes there are issues because they're ahead and testing out new features and things. So make sure you specify this specific release, which is specified in the code lab. And then you can use the ag-v command to see which version you have installed, which I do indeed have 0531. So sorry, Tamimi, the question was topics versus queue endpoints. So as I mentioned earlier, there is a few reasons that you can use topic endpoints. I believe all of them are if you're using JMS and functionality around JMS. I believe it's topic selectors. I'm not 100% sure, but what you can do actually is if you go to the Solace community and post this, I'll find somebody that does know, or I'll research this later and get back to you in the Solace community. So for those of you that don't know, oops, I don't want to create a new tab there, but I want to create a new tab here. If you go to solace.community, this is our Solace community, developer community homepage. And so here you can get information about upcoming events, but it also has a forum built in. So you can ask questions such as, when should I use a topic endpoint versus a queue endpoint? And then we have a lot of people that, a lot of Solace experts in the forum that will answer some of these questions. And also the cool thing is it's available later. When I forget that reason, I can go search for it and find the answer again. But yeah, please go ahead and sign up for our Solace community and ask the question here. All right, so we installed the generator. Thanks, Dev Ninja. Please join the community. So now that we installed the AsyncAPI generator, let's go ahead and develop the ride drop-off processor. And so now in order to do this, we want to use Spring Cloud Stream since we just learned the basics of it. And we want to generate most of the code for us. So what I'm going to do now is go back to our event portal. And in the event portal here, the ride drop-off processor is the application that I want to consume. So I'm going to say right-click AsyncAPI. I'm going to get it in YAML format because it's a little bit nicer to read than JSON, and choose download. And so if I open this file now, what screen did it open on? Okay, oh, there it is. All right, I can see, as Tamimi talked about earlier, this defines the different components of my application. And so the components include schemas, so the ride average payload and the taxi status update payloads. So these are the schemas that define the payloads of our events. The messages themselves that are exchanged over the brokers. We have the ride average update message and the taxi status update message, and the channels which those messages are exchanged over. And then, of course, generic information such as the version of AsyncAPI that we're using and the title of our app, etc. So now that I have this is a machine readable format, right? So like not as pretty as the event portal, that's more of a human readable format, but I can use this with the AsyncAPI code generators. So if I jump back here to our code lab, what's the next thing I need to do? We just looked at the AsyncAPI document we downloaded, but next we want to actually use the generator. So for Spring Cloud Streams, there are a few extensions. And so these extensions can be found. I do AsyncAPI Spring Cloud Stream. The template is available on GitHub, which is where AsyncAPI does a lot of their documentation. And so in here, it defines, how there's compliance with the specification, how methods are defined in the generated code, how they're named, and a whole bunch of other things. And so if we scroll down, there's parameters that can be used, and there's specification extensions. So all the information is available for you to find. We're going to use a few specific extensions as part of this to make our code look, kind of work how we want it to work, right? So in our design, right, we want ride drop-off processor to take in taxi status updates and output ride average update events. And we want to do that in the same method. So what we're going to do is we're going to add the SCSt function name extension under our different operations in our AsyncAPI document. So the operations here are publish and subscribe. And so I want my application to publish from this function name, and I also want it to subscribe in that same function. So this tells the code generator I want to handle the events arriving on these channels.
You might want to zoom in a bit, Marc.
Good call.
Perfect. Awesome. Yes, great. Perfect. Thanks.
So no problem. So I want to handle events being published to this channel using this method, and events arriving, because I'm subscribing, on this channel using this method. And then the second thing that I want to do here is define my queue. So using Solace, if you define the SCSt destination, this defines the queue, or a queue name that those messages will arrive on. Oops. So I want to put that under subscribe. And so we're going to be working on enhancements to kind of add some of these things for you in future iterations of the event portal and future updates. We're working on some cool functionality to make this tool even more useful for developers. But for now, we're going to go ahead and add that in manually. And now that I have that, what's my next step? I think my next step here should be to actually generate the code. And so we installed the generator previously, and now we're going to actually use the generator with the Spring Cloud Stream template to generate the code. So I'm going to go ahead and copy this AG command, and then I'll kind of explain it here. So it's already running. But basically, I'm saying the output directory that I want the project to go into. So this is going to generate a Spring Boot, Maven Spring Boot project in this directory. I'm going to use the Solace binder. You could, of course, use Kafka or Rabbit here. There's also the option here of using reactive or non-reactive. So I didn't mention programming models earlier, but Spring Cloud Stream does support reactive code. So by using reactive here, it will actually use Flux in the generated code. So we'll see that in a minute. I included Spring Actuator. So this exposes some endpoints for monitoring. It's a Spring Boot project that you could check out. I can name my Maven artifact ID and group ID and Java package. And then I have my connection information here. So the connection information in the code lab is actually already pre-configured with the publicly available data feeds. So you don't have to change this to your messaging service. You can just use the messaging service that's already available publicly. I then pointed to the YAML file that we just downloaded and modified from the portal. And the last thing here is the generator template that you want to use. And in this case, we're using the Java Spring Cloud Stream template because, hey, we want a Spring Cloud Stream application. So if I do a list here, I can see I have my ride drop-off processor application now. And I want to import that into my IDE. So I'll go ahead and close the stuff that we were using before. We'll go ahead and close the project just so it doesn't get in our way. And I want to import this, and it's a Maven project. So if you don't have if you don't have Spring Tool Suite, you of course probably have a Java IDE that can import a Maven project. Otherwise, it wouldn't be much of a Java IDE. So let me go to the directory. Let's see, workspaces. All right, where is this directory? That might be useful. Dev temp SpringOne repeat. Dev temp SpringOne repeat. And if I just open that, it finds the ride drop-off processor, and I'll go ahead and click finish. And so we actually generated a Maven Java project. So again, unfortunately, I can't zoom in on this on the left. But once I open this, can I? No, it doesn't let me zoom in. So essentially, it created the application in the Java package that we defined. It also created the ride average payload and the taxi status update payload. So these were these POJOs were generated from the schemas that we defined in the event portal. So that is super useful from the perspective of I didn't have to hand create all of these objects myself, and Spring Cloud Stream will automatically convert messages to these payloads. The other cool thing that this actually did, and this is probably the most useful thing here from a Spring Cloud Stream perspective, is earlier we talked about configuring Spring Cloud Stream. Well, the generator just did that for us. So it defined our function definition. Remember, we said we wanted a function called process drop-off ride averages. It bound the channels. So these bindings here is what tells Spring Cloud Stream what topics to publish to or what queues to subscribe to consume from when you're using the Solace binder. And it applied even like the topic subscription to those queues for us. It threw in our credentials. So all the stuff that makes it, this will make it more simple and consistent if you're developing 10 or 100 event-driven applications, by being able to go from your design straight to having kind of the messaging skeleton all wired up for you. And so you're handed this application.java file, and this is basically ready. Again, it's a Spring Boot application as we discussed earlier, and we have our function here that says, I'm going to receive a flux of taxi status update payloads, and I'm going to output a flux of ride average payloads. So if you're not familiar with Flux, this is included by Project Reactor. And so Flux is basically a stream of events that is, it could be an infinite stream of events. So we're going to be receiving an infinite stream of taxi status update payloads and publishing an infinite stream of ride average payloads. So let me go back to the code lab and make sure I didn't miss anything here.
And I'll take this as an opportunity to mention as well that we have a bunch of videos in our YouTube channel. One of the videos, if you look it up, it's called Developing Event-Driven Microservices Using Spring Cloud Stream, where myself, Marc, and Oleg from Spring Cloud got together on a panel-like video where we did live coding with Spring Cloud Stream. And we talked about in details for these different features. So if you want to dig more into it, feel free to navigate to our YouTube channel and look up the Developing Event-Driven Microservices Using Spring Cloud Stream on our YouTube channel under the Developer Virtual Events playlist.
Yeah, and that was a super cool session. And one of the reasons for that was it was a unique opportunity to really talk to Oleg. And so Oleg is the lead developer on the Spring Cloud Stream project. And so there's a lot of cool nuggets of information in that session. So you can definitely check that out. Obviously, if you have questions at any time about Spring CloudStream, you can of course ask them, in the Solace community, and we'll do our best to get you answers to your questions. So we already imported and explored the project. I kind of talked through a lot of this. So the next thing we want to do, though, is subscribe specifically to drop-off events. So remember, in the portal, we defined our topic using wildcards. So right now, the portal and AsyncAPI don't yet support dynamic subscriptions and things like that. So we are working to improve that. But in the meantime, we're going to update our subscription to subscribe to drop-off events. And so we do that in our application.yaml file. And so we see we had this nice long subscription here. But what I'm going to do is say, I want to replace this ride status with just drop-off, because I want drop-off events. So I replace that. And then you know what? I don't care about the rest of these levels. I don't care about which driver it is, which passenger it is, latitude or longitude. I want everything. So I'm just going to say greater than, which is a Solace wildcard symbol. And it will give me all of those events. So again, this allows me, using Solace topics to filter for exactly the events I want. So I only get drop-off events for all drivers, for all passengers, for all locations. And so I can go ahead and save that.
Wildcards, Mark, we have a question from Twitch. Are there other wildcards used at Solace? I know you used the greater than. People are asking about other wildcards, if there is any.
Yeah, so greater than is one of our wildcard symbols, and so greater than is multi-level. So a level being, delimited by these slashes here. Backslashes. So greater than says give me everything else. But what you could also do is say there was multiple versions and you wanted to receive all versions, you could use a asterisk, and an asterisk is a single level wildcard.
Right.
And it can also be used as a partial single level wildcard. So you could do, like, if you had multiple subversions, you could do v1 star to get like 1.1 and 1.2, etc.
Right.
So yeah, you have asterisks and greater than, and so that works for Solace message format. There's different ones if you're using MQTT because Solace is a polyglot broker that supports multiple protocols, but for Solace message format, it's greater than or asterisks.
Right. Thanks.
So thank you for that question.
If anybody has any questions, feel free to ask it on the chat. We've had interactive people. Yazad, thanks for Yazad Irani, thanks for asking a bunch of questions so far. Feel free to reach out to me on solace.community, Yazad. I will give out a swag bag for you. You've been very helpful and interactive with us so far. So if you're still on the stream, I'm available on solace.community. Reach out to me and get in touch with me. I'll give you your link to get a swag bag.
Yeah, for sure. Oh, wow. I didn't realize we only have 6 minutes left till the top of the hour. So I do want to get through step 6 here. So I'm going to move on to publish to a personalized topic. So since we are using a public event broker, technically if I'm running the app and Tamimi's running the app and all of you guys watching are running your own apps, then we're going to use our unique name as part of the topic, just to make sure that we don't have conflicting events flowing across the broker. So to do this, I'm going to go ahead and update the output topic to use my unique name. And so that's the out01. And so this is where output events go. And for my unique name, I'll go ahead and use Marc since it is my name. Hopefully there's no other Marcs with a C that are also doing this right now. And so obviously, in theory, in practice, you would use the real topics that come from the event portal that match your real design. So this is just because we're all sharing the same broker. And the next thing we're going to do is fill in our business logic. So I'm going to go ahead and just copy this so I don't have to code it since we're running out of time here. I'm just going to copy it here. And one thing that I will point out, and I go through this in the code lab, is we are using Project Lombok. So you need to actually add this to your Maven dependencies. So Project Lombok is a really cool project that allows you to more easily define objects, and it automatically creates like getters and setters and constructors, etc. If you're using Spring Tool Suite or anything of a Spring plugin, you can actually say edit starters and add it here. So I'm going to go ahead and just type in Lombok. So you can add it like this, or you can add it straight to the Maven POM using what's in the code lab. Oh no, I have an issue here. What is my issue? Total passengers, get ride count. All right, so it wants a whole bunch of different things. Okay. What's the quickest way to fix this?
What is he complaining about?
Oh, I don't have the available constructor available because we updated the event and it has a lot more things in it. Let me just make a new constructor here. I'll do here. So we'll just delete this real quick. And so I want one that just has the total meter. So I've got the meter, passengers, ride count, and date. So I just want the meter first. So I need to update this code lab. Meter, passenger count. I think I actually have the wrong schema in the portal, so I think that might be a problem. Meter, passenger count. Yeah, so I'm actually developing from the portal. Apparently I have the design wrong. What did I say? Total meter, passengers, ride count, and date. Yeah, so this is totally wrong.
So it's just the schema that you had, right?
Yeah, so it's going to say integer. Count. 8. All right, why don't I do this actually? If I go over here, the ride average update. If I go to my schema, I'll see this actually doesn't define the ride average update that I would want. This actually defines the schema of the taxi status updates that are being published. So I do wonder if I have the real schema somewhere.
Okay, see what you're saying.
That I can capture it from real quick.
Maybe I can find the real schema. 1 second, I could give it to you.
Actually, I think I know what I can do. So all the code for this workshop is available in GitHub as well. So this is linked on in the code lab that we're walking through. On the what you'll learn here, we have the solution in the GitHub repo. And so assuming that I have the solution right in this GitHub repo, I can probably just steal it from here just so we can move forward. The ride drop-off processor and the ride average payload should be this. So I'm going to take an action to update the schema to be correct in the code lab, but I'm just going to overwrite it for now. So it should be that. And so now that we have the right POJO there, our code compiles. And so what we can see what happens here is we defined this. This was the method that was generated by Spring Cloud Stream, and we had to add our business logic. So what we do here is we consume from the flux, and we say, for a window of 20 seconds, calculate the average, and then we essentially output. So the calculate average takes in that in that flux and does a kind of reduces it to a single accumulator object, which we define down here. And so what that does is it has a ride count, a total meter, and total passengers. So it counts up the total rides, it counts up the total meter, it counts up the total passengers, which allows us to create a new ride average payload from that. And that average payload, now that my object is right, has the average meter reading, it has the window duration of seconds, so we know that it was 20 seconds, it has the average passenger count, the window ride count, and the timestamp for our applications downstream to consume. So now that we've added our business logic, I can actually run this. So sorry about that hiccup there. You can tell we're doing this live.
Yay, live code.
And so as payload, as ride drop-offs occur, we actually see that our application consumes them. So I can see the ride ID and the heading and information that was consumed from that. And so somewhere in here, it should say that, yeah, of course, the last thing, the ride status was drop-off. So we're only getting ride drop-offs. And then every 20 seconds, our application is creating a ride average payload event. And so our application is now running. And so we've actually created in our code lab now, we've now gotten information from the taxis into Solace. We've received them, we're processing them in the ride drop-off processor, and we're publishing them back to Solace to be consumed. So that was through step 6. So step 7, we're over time now, so I'm not going to walk through this on this session. But again, this is public, so you can do this yourself. You can extend the event-driven architecture to add the ride drop-off consumer and develop the ride drop-off consumer. So it'll actually consume those ride average update events. And this application is actually super simple. It's even simpler than the application that we just developed. So you basically just say you have one function and you bind it to the specific topic, and you just write a simple app. And so it's this like 3 lines of code just to log that you received that. And so then you see you will have essentially completed the exercise by adding the ride drop-off consumer. So I guess kind of to wrap this up, I wanted to just touch on, hopefully throughout the session you saw how the Solace Event Portal is a useful tool to visualize your event-driven architecture and really discover what events exist, but also to collaborate with your team to kind of kickstart the development, right? So you worked with your architects to actually define, the architecture, and with other developers to consistently keep this model updated of what's actually in operations and what's being developed. And you can use AsyncAPI to define your application and actually generate code. You can also generate documentation from that code to share what events are available using that. And then, of course, we use Spring CloudStream to actually develop our event-driven microservice. So just like the features and functionality that the framework provides you makes it super easy to develop these apps. And really, it's kind of like the insert your business logic here. So Tamimi, I'm going to pass it back over to you unless we had any other questions or anything.
We have just one question about topic strings. If I believe here the question is about receiving the original topic string of any incoming message. Any incoming message that you get, you can dump the information about the message, including the topic that it was received on. Yeah,
so in general, with most of Solace's APIs, there is the topic that a message was published on is in the destination header. So you can do a message.getDestination, and that will give you the topic that a message was published on, and you can do things with that. Now in Spring CloudStream, we're actually working on an enhancement right now. So the next version of the binder will make all of the SMF headers available within the Spring message itself. And so you'll be able to get that destination then. I believe right now you can actually do it using the @header accessors, but I'd have to go double check on that. And so what you could do, so let's say that you're writing your own method here, and I had I'll just say consumer. You can say, hey, give me the actual message, and let's say my message was well, let's just say it was of type taxi status update payload. And then we just wanted to process that. So if you did it like this, you would actually have access to the Spring message itself. And so you could actually like access the headers from here. And I believe you can say, like, I want header destination. I think this will work. It's something like this. So I have to go look into it. But there's something like this that you can do to get access to the header now. Oops. Let's see if this actually works. Header, is it string destination? Yeah, so I think it's something like that. And then you'd actually be able to use that header in your code. So I have to go double check, but I think the answer is, I believe there's a workaround now. In the next version of the Solace Spring Cloud Stream Binder, you'll be able to have, there'll be a getter for every Solace header, and then for custom properties, you'll be able to get those as well using a generic getter, like by name of the property.
Perfect. I hope this answers the question. And just to confirm as well, if you have any follow-up questions, or if you have something else in mind that you wanted to ask, feel free to join our Solace community on solace.community. You can see it at the banner down below. Yeah, you could go ahead and ask us questions there. Marc, thank you very much for this. That was an interactive session. I enjoyed it overall, having this to do with you on this call. And for all the audience who joined us and interacted with us, thanks again for making this session interactive and asking questions. I know some people enjoyed this session. Yes, indeed, it was a packed session. We had a lot of things to cover. We covered a lot of things in Spring Cloud Stream, the event portal, AsyncAPI, connecting everything together from designing the microservices. So that was great. Yeza, thanks again for being super interactive. So a reminder, feel free to reach out to me on Solace Community, and I will give you the link to get your swag bag. Apart from that, I think that's all what we had for today. Mike, did you have something else to say?
Just one quick thing is, so if you are interested in learning more about using the Solace Spring Cloud Stream Binder, I did want to share the Solace Spring Cloud GitHub repo is where this exists. And if you go to our Spring Cloud Stream starter here, this is where it has all the documentation about our binder. And also, of course, you can have issues here to follow the enhancements that are coming. So there's information here about better error handling improvements and wildcards and stuff like that. We talked about a few things throughout the session that are defined better here. So there's a section that talks about failed error message handling. So this talks about the Spring retry. So retry error handling from the framework level, but also from the binder level. And also something that's cool for people that are using Solace topics, message target destinations, is you can actually publish to dynamic destinations using Spring Cloud Stream as well. So kind of food for thought there. There's information here. There's also posts in the Solace community about this. I'm hoping to come out with a blog about this at some point in the next few months. I'm trying to bubble it up the priority list as well. So I just wanted to make people aware of this repo as the place to go to learn more about the Solace Spring Cloud Stream Binder. And also one last reminder, these code labs are available on codelabs.solace.dev. So after the session, you can follow along and do these on your own. If you filter by Spring, it's essentially these two here, the design to code and the Spring Cloud Stream basics. So yeah, that's all I had. Thank you to Mimi, and thank you everybody who stuck around. Let us know if you have any questions in the Solace community. And if you're watching us on YouTube, please like and subscribe to see our future developer events.
Yes, we have a bunch of developer events that are coming up next soon. So feel free to like, follow, and subscribe to us on.
Wow, I think we just lost Mimi there. But yes, thank you, everybody.
Yes, I am back. But yeah, thanks everyone. And yeah, if you have any questions, feel free to ask them. Thank you all.
All right, bye.
Bye, Marc. Thanks.